Hello, calculus type people. Hope you're having a fantastic day today. Okay, for this one, the back of the notes here, this should have been explained in class, and I'm saying that because I'm recording this in the past when I haven't actually explained this in class yet. So hopefully I actually explained this in class. And so let's just go to the front portion here, where it says the fundamental theorem of calculus part 2 continued. All right. It says let f be a function whose domain is -3 to 5. The graph of f is shown. So the graph of f is shown. This is f. Technically, this is f of t, right? F of t, yeah. That's f of t. And it says let g of x be the integral from 2 to x of f of t. So it's kind of like you plugged in your x here. It's the integral of f of x. What this means is that if you have g prime of x, if you take the derivative of the integral, you'll end up with f of x, right, times the derivative of x. We learned this yesterday. 1, which is f of x. Fantastic. The derivative of the integral is a function. Fantastic. Now what that allows you to do is take something that's defined as an integral, it's defined as an integral here, and evaluate it. So g of -3 is really trying to plug -3 into this x right here. So let's plug it in. That's the integral from 2 to -3 of f of t dt. This is where one of those obscure little rules is going to come into play, and I'm excited because they just started selling these at the gas station by my house. These things are pretty awesome, except that I think my heart is racing a little bit too much. That's beside the point. See how this is a negative number on top and a positive number on bottom? We can't have that. So what I'm going to do is make the integral negative, and I'm going to switch them bad boys. I'm going to put that -3 down in the bottom where it belongs, and I'm going to put that 2 up top. Now somebody had asked me, and she knows who she is, about why does b have to be on top? B always has to be the bigger number. And in situations like this is where pulling out that negative from the integral is going to become very useful. So that's f of t dt. Okay, so bell. Not my bell. Okay, so let's actually figure out what's happening here. We've got our negative sign, and I'm finding the area under this curve, right? From -3 to 2. So I've got 1, 2, -3 here, and 2 here. Very interesting. Very interesting indeed. Well, excuse me. What I'm going to do here is bust this thing up. I've got 2 triangles, right? So it's 1/2. Your base of this one is, now it's, since these go to the same point, I'm actually going to treat this triangle and this triangle as the same triangle. Pretty sure I can do that. If I screw it up, sorry. What I'm going to do here, it's 1/2. My base is 1, 2, 3, 4 units. Times my height is -3. Very important that I remember the negative there. Plus this guy right here. 1/2 a base of 1, and a height of 3 units. Hope this works out. And this is going to be my negative sign. That's 2 times -3 is -6 plus 3/2. Fun. So this is going to be it's going to be equal to a positive, let's change that 6, so positive 12/2 minus 3/2, 9/2. Fantastic. fantastic. Hope you can see that. Let me zoom in. There you go. 9/2. Never again. Look at this. I mixed a bracket with a parenthesis. Never again. Okay. Number 2 says find the instantaneous rate of change at G at x equals 4. Instantaneous rate of change. Did they just ask me to find G prime of 4? I think they did. They just asked me to find G prime of 4. Well, what? Hang on. G prime is F. So did they just ask me to find F of 4? I think they did. 1, 2, 3, 4. 1, 2, 3. Bam. Calculus. Number 3. Knocking these things out of the park. Like Jose Canseco. Is that his name? Sounds right. Number 3. Write the equation for the tangent line to the graph at x equals 4. Tangent line. That means I need a point. And the point is going to be G, right? So I need 4 comma G of 4. And then a schlop, which is going to be G prime of 4. I already found G prime of 4. It's right up here. It's 3. Oh my gosh. I'm having such a fantastic day. 0.4 comma G of 4. Well, if I plug a 4 into G, what am I going to get? Now, see, that's the problem here. Because plugging in a 4 into G of x, if you'll remember, G of 4, rather, is the integral from 2 to 4 of f of t. Right? F of t dt. Which is going to be the integral of 2 to 4 is the area under the curve from 2 to 4, 2, 3, 4. So that's this area. Let me erase this now that I don't need it anymore. It's going to be this area here. Yay. Wait, no, not that one. 1, 2, 3, 4. Here. There we go. Okay, so here's how I'm going to approach this thing. Obviously, there are ways you could do this. You could find the area of this rectangle and then add the area of the triangle that's on top of it. You could find the area of this trapezoid from 2 to 3 up here. So 1, 2, 3, 4, this trapezoid right here, and multiply it times 2. I think that's what I'm going to do. I feel fine about that. Let's do that. I'm going to have 2 of 1/2. My height on that one will be 1, if you will. And my bases are going to be 1, 2, 3, and 1, 2, 3, 4, 5, 6. 3 plus 6. So 6 and 3 is 9. Halves times 2 is 9. So my point is 4 comma 9. That looks messy. Four comma 9. Let's do it. Y minus y1 equals m times x minus x1. Tangent line. Done. Time to change pencils. Lead's getting dull. Number 4, at what x does g of x have an absolute min or max? Now this one actually requires a little bit of thought to go into it. G of x has an absolute max or min, so I have to check 2 things. When I see that word absolute, I know I need to check critical values and endpoints. CVs and EPs, critical values and endpoints. Critical values, this guy, is when g prime of x is 0, right? Critical values come when g prime is 0. Endpoints are just the endpoints, which are -3 and 5. So I'm going to come over here to the right, and I'm going to kind of set this thing up here, or excuse me, to the left. I need to find my critical values first, right? I'm looking for where g prime of x is 0. Well, g prime is f of x. And so I'm going to go back up to my grid here, and you can look up at your grid, and you can see where does it equal 0. Well, other than your endpoints of -3 and 5, it equals 0 at 1. And that just came from right up here on my graph. This is an endpoint, so I'm not going to worry about that. I'll test it later. I'll test this endpoint later. Here's where it's 0, and that's at 1. So yay, easy stuff. So let's test 1 and make sure that it is in fact either a maximum or a minimum. So g prime of x, which is f of x, I'm going to test somewhere between these points. Alright, so is the value of f, this is the graph, right? This is what I have on the graph. Is it positive or negative between -3 and 1? Well, it's all negative. Alright, is the graph positive or negative to the right of 1? Well, it's all positive. So the slope of g goes from negative to positive. So we have a min, right? So we have a minimum. And let's test the other points. So I'm actually going to test my endpoint, what point I came up with, and my other endpoint. On the test, I will tell you that testing the endpoints is one of the few things that was missed when it came to doing absolute max and min. There was a free response question where you had to test the endpoints, and no one tested them. Not no one. A majority didn't test them. Okay, so let's plug in g of -3. We already found somewhere, didn't we? Oh, yeah, up at the top, number 1. We already found g of -3 is 9/2. G of 1, oh, I should have spaced this out a little bit, because I'm going to need to write integrals in here. Let me do this. G of 1, G of 5, just to give myself some space. G of 1 is the integral from 2 to 1 of f of t dt, which I need to change this actually. It's going to be the negative integral from 1 to 2 of f of t Sorry for writing so small. Let me zoom in here. I'm running out of room though. I gotta be careful. Which is going to be negative, and I'm looking up at my graph here, from 1 to 2. It's a triangle. My width is 1, my base is 1, my height is 3. 1/2 base times height. That's a -3/2. G of 5 is the integral from 2 to 5. F of t dt, which is from 2 to 5. This is a, ooh, you know what? Is there a way I can get around this? I think there is. We already found. What have I already found? I've already found something. I've already found 2 to 4. 2 to 4 was 9, and then we can integrate from 4 to 5 as a... No, here. I'm not going to do that. I'm just gonna do it. Okay, the integral from 2 to 5. I've got a triangle from 3 to 5, and a trapezoid from 2 to 3. So trapezoid first, 1/2. My height is 1, and that is 3 plus 6. I did already do that somewhere. I did that, I don't remember where. Somewhere. Plus, and then my triangle, 1/2. From 3 to 5, it's going to be a base of 2 times the height. 1, 2, 3, 4, 5, 6. Okay. 2.5 will cancel. I've got 9/2 plus 6. So 9/2 plus 12/2 is 21/2. All right. So I know g of 1, or excuse me, g prime of 1 gave me a minimum value, right? So there's a minimum at 1. Makes sense because 1 is negative, right? So here's how I'm going to write my, oh, you can't see that. I'm so sorry. So g prime of 1, g of 1 gave me a minimum value at -3/2, so that is the lowest value here. So g of 1, what am I doing? We have an absolute min at x equals 1 because it's the lowest number, and an absolute max at 5. Testing for absolute extrema is a pretty in-depth process. Pretty in-depth. Last one. This one ain't that difficult. At what x does g of x have a point of inflection? Okay, so point of inflection, I'm looking where g double prime of x, which is f prime of x, and I'm looking for a place where f prime of x is changing from increasing to decreasing, right? I'm looking where f prime has a sign change. Yes. I'm looking at where f prime has a sign change. That's where f prime, the slope of f, is changing from a positive value to a negative value. So all I'm going to do here is set up a little x line, -3, and then what I'm doing here is looking up here. It changes. Your slope is undefined right here at 0. It's undefined at 3, and then back to the x-axis at 5. So -3, 0, 3, and 5. And the slope between -3 and 0 is negative. It's going down. It's going to be positive between 0 and 3, and then negative here. So there's going to be a point of inflection at x equals 0 and 3 because g double prime of x equals f prime of x has a sign change. Boom! I just lost my pencil.